In this video, I'm going to solve a sample problem about moment distribution method. Here's the problem. Determine the reactions for the beam shown in the figure using the moment distribution method. E is constant. Okay, so the first step is to solve for the fixed end moments. So for members AB and BA, zero ang fixed end moment. Okay, no load man. So we only have fixed end moment for members BC and CB. Now for a uniformly distributed load, the fixed end moment is omega L squared over 12. And for MDM, we have assigned convention na sa left na moment, negative kay counterclockwise, and sa right, positive kay clockwise. So negative omega L squared over 12. Omega is 240, length is 20. And MBC is negative 8,000. Due to symmetry, the moment of member CB is same in magnitude, but then the sign is positive. Okay. The next is compute for the member stiffness. And the formula is for EI over L. But since E is constant, we will use the relative stiffness, which is equal to I over L. Uh, so for EB, it's the same as BA, no? Same value of I, same value of L. So I 300 over L 1520. And for BC and CB, the stiffness is 30. Now for this problem, we are going to apply the modified stiffness. Now, modified stiffness is applied to members where the far end or the opposite end is a simple support. So in this case, BC, no? So sa interior joint lang na. So at joint B, two members are connected, BA and BC. Now in the case of BA, we cannot modify the stiffness since the opposite end or the far end is fixed. So di pwede. We can only use modified stiffness na ang opposite end is simple support. Like in this one, C is a rocker. So we can apply modified stiffness sa member BC. And the modified stiffness is equal to 3/4 of K. So 3/4 of this value. For BC, 3/4 of 30. That's 22.5. Okay. So after this, let's compute for the distribution factor. Now the formula is this, K over summation of K. And this formula is only applicable sa interior na joint. Sa end support like A and C, na value like for fixed, the distribution factor is 0. And for a simple support, roller, rocker, or pin, the distribution factor is 1.0. So for AB is 0 since fixed. And for BA, the distribution factor for a member is equal to the stiffness of the member divided by the sum of the stiffness connected sa joint. Like for joint B, ang members connected are BA and BC. So we have this one. Distribution factor for member BA is stiffness of member BA over the sum of BA and BC. So, uh, 20, no? 20 for BA and for BC, it's 22.5. So, 8 over 17. And next, BC, distribution factor of BC is stiffness of BC over total sa joint B. Okay. And to check, dapat ang total distribution factor for the interior joint should be equal to 1. So, i-add mo ang 8 over 17 and 9 over 17. The sum is 1. Okay. And lastly, for CB, it's 1.0 by simple support man. After this, then we will construct a table. So, sa table, we have four members, EB, BA, BC, and CB. And joints, joint A, B, and C. And then next row is distribution factor, and then fixed end moment, balancing moment, carry over, balancing. So, every time mag-balance ka, that's one cycle. So, for this one, let's have a maximum of 4 cycles. So, cycle 1, 2, 3, and 4. Okay. So, let's put the distribution factors. No? So, 0, 8 over 17, 9 over 17, and 1. This one. And then for the fixed in moment, AB and BA 0 and BC negative 8,000, CB positive 8,000. Okay. So, next is balancing moment. So, whatever the unbalanced moment is, i-balance mo by the same magnitude but opposite in sign para ma-zero, especially sa interior na joint. And for end support, it depends on the distribution factor. Okay. For EB, this is the fixed in moment 0, so therefore ang balancing niya 0. So, while for joint B, interior na joint, okay, dapat ang total, after i-balance ni mo, the total must be 0. So it means na for the two values, i-add or subtract, and the result is the unbalanced moment. So in this case, 0 and negative 8,000. So the unbalanced moment is negative 8,000. Therefore, you have to balance it by the same magnitude but opposite in sign, which means na the balancing moment is positive 8,000. So ang positive 8,000 will be distributed sa two members BA and BC in proportion sa distribution factor. So positive 8,000 times 8 over 17, the result would be the balancing moment for member BA. And then for BC, positive 8,000 times 9 over 17. Okay, we have positive 4,235.294. Now for joint C, we have this moment, positive 8,000, unbalanced. So we have to balance this one by negative 8,000. And then negative 8,000 times distribution factor na 1, it's negative 8,000. So after this, carry over. So carry over 1/2 of the balancing moment to the opposite member or end. So AB, i-carry over sa BA here, and for BA, carry over 1/2 of the value of this, kining nga value, 3,764.706. 1/2 of this, i-carry over sa member EB. No? So, para simple, let's have this one. Para ma-remind ka na ang carry over sa opposite end. Also for BC and CB. So 0, 0 lang. For this one half of this, we have 1,882.353. Now, for member BC, since modified ang stiffness, that is why red ang color para to indicate na modified ang stiffness. The carryover of the carryover moment sa BC going to CB is, oh, this is CB. Sorry. This must be CB. Okay. The carryover moment for a member with modified stiffness is 0. So instead na positive 2,100 plus 0 ang carryover for members na modified ang stiffness. It was explained. This is explained already, or this was explained already pag explain sa concept sa MDM. And lastly, for CB, this is CB. Carryover of negative 8,000 is negative 4,000. And the next, i-balance. So, unbalanced moment. So, i-balance siya by negative 1,882.353. But then the distribution factor is 0. So, therefore, ang balancing moment niya 0 ra. And for joint B, okay, between 0 and negative 4,000, the unbalanced moment is negative 4,000. So, i-balance siya by positive 4,000 and will be distributed in accordance or in proportion sa distribution factor. So, 4,000 times 8 over 17, we have this one. And 4,000 times 9 over 17, we have this one. And then 0 times 1, 0 lang. And then carry over. Half of this carry over sa BA, 0. Half of this carry over sa AB. And again, for BC, with modified stiffness, the carryover moment is 0. And for CB, 0. Again, CB niya. And then balancing. Unbalanced moment ang positive. So, the balancing moment is negative 941.176 times distribution factor 0. And for joint B, 0 na tanan. And then CB, 0. So, up to 3 cycles lang ta instead of 4 cycles, kaya 0 naman. So, the next step here is add all the values starting from the fixed in moment, then the balancing, carry over, balancing. So, for member EB, 1,882.353 plus and 941.176. Positive 2,823.529. For BA, this one, BC, and for CB, 0 lang. Okay. Dapat ang value sa BA and BC the same but opposite in sign. Dapat equal, or if not, small difference, round of error, okay lang. Round of error. So after this, we will compute for the reactions. So sa joint A, okay. Now, why clockwise? No? Okay, positive man. And we have a sign convention na sa MDM na clockwise movement positive. And since positive ni, so clockwise movement. For BA is positive, so clockwise, while BC is negative, so counterclockwise. This one. BA is clockwise, BC is counterclockwise. Same magnitude. Okay, while ang CB, it's 0. So after this, cut a section at B, and then isolate beam AB and isolate beam BC. We have this one. And let's apply the values. At A, we have this moment. And then sa B, BA clockwise, sa BC counterclockwise. Same value. And then we start with member AB. Consider this one as simply supported. Not simply supported, but we can solve for the reactions. So, sa A, no naman ang moment. So, ang ano na ni sa A is only vertical reaction. Let's assume na upward. Let's assume first na upward. RA. And for B, since duha, so RB1, and then this one is RB2, and then RC. Okay. So, starting with member EB, let's sum up moment about A. And this one is clockwise, that's negative. So, ang convention na to, in summing up moment is counterclockwise, positive. So, since clockwise ni negative, clockwise negative, and then RB1 positive. We have this one. Negative 2823.529 minus 5647.059 plus RB1 times distance 15. The value of the reaction at B is 564.706. And considering beam AB, there is no other vertical force. Therefore, the value of RA should be downward para i-counter ang RB1. So this must be downward. Same value. 564.706. And for beam BC, let's sum up moment about C. So 5647 is positive counterclockwise. RB2 is negative clockwise, while the uniform load is positive, that's counterclockwise. We have this one. Positive 5,647.059 plus, for the uniform load, compute first the resultant. That's 240 times 20, this one. And the resultant is acting at the center of gravity. The center, so the moment arm is 10. And minus RB2 times distance 20. So the value of RB2 is 2,682.353. And lastly, solve for RC. We sum up force vertical. And we have this. XRC plus 2,682.353 minus resultant sa uniform load 240 times 20 is 2,117.647. And then after this, apply sa beam, like sa support at A, it's downward. And sa B, i-add ni. You add RB1 and RB2, and the total is 3,247.059. And then C na yun. Okay. So, this is the final result for this problem. So, I hope that you have learned something from this video. Thank you for watching. Please like and share this video. Subscribe also. Thank you again.